Very good. So yeah, I'm Chris Beckman. Excited to be here. Long-time Linux Fest Northwest participant, first-time speaker. The first time I came here, I feel like I had no idea about what half the conference talks were about, and found them very overwhelming. But I had I put Linux on a laptop. I was here. I was ready to go. I learned quite a bit, and over time, not just through Linux Fest, but through learning elsewhere, I've made this my career and really enjoyed it. So I do give Linux Fest some credit for really getting me going on Linux in a real way. So anyway, let's talk about identity-aware reverse proxies. So first of all, computers, fear them, love them, play MUDs on them. This is me. I found it while going through a family photo album. This is my IBM PC, and it had MS-DOS, so I'm sorry, everybody, not Linux. But I was introduced to Linux later. And these days, I'm a principal security engineer at a company called Taxbit. I'm in Seattle, but we're actually based out of Salt Lake City, Utah. We make tax and accounting compliance software, and yes, much of it runs on Linux. So in fact, I think all of it runs on Linux. I, over the years, have been working in startups dedicated to AI and blockchain. I was recently told that you cannot have those in one sentence, but I've done it. I also hold my Juris Doctor from the University of Iowa College of Law in Iowa. So, agenda for today. What is an IRP and how do they work? Why do we want one? IARPs versus VPNs. What options do we have? Building at the small scale, a small demo, and then we'll wrap it up. So first of all, what is a reverse proxy? So before we understand the identity part, let's get our basics down first. I've heard reverse proxies called the Swiss Army knife of DevOps, which is to say if you need to get something that is hosted somewhere in some network, can't move the thing, but you do need somebody to be able to access it elsewhere, you can basically put a reverse proxy there and get a mirror of it. And that is how I think of it. It's like a mirror, and you're looking at the reflection of the light from the original thing. It's serving you those requests through that proxy. Why is it a reverse proxy? Well, you may have had a proxy at work where you have to put in proxy and go through something very slowly and it filters your internet. It doesn't do that, it's the opposite. It's stuff coming back in. So, typically you can run a reverse proxy on Apache, on basically any modern web server typically can also function as a reverse proxy. Here we have a sort of a diagram that walks it through. I know it's a little small, so I'll walk through it piece by piece. Your external clients send out an HTTP or HTTPS request to your reverse proxy. This could be in a container, in a VM, it could be on a bare metal server. And then what it's doing is basically forwarding those requests to the web server and then sending them back to the user as if it was the server itself. And so it can also act as a way to load balance across various servers and to essentially move where they're at. But it doesn't have any authentication in it. It just puts up whatever was there. If you have Hello World on these, you're going to get Hello World from the reverse proxy. And so some genius came up with the idea of, well, what if we made it so that you had to log in first through this? And that's where we get identity-aware reverse proxies. I first started working with them in Google Cloud. So Google Cloud loves their reverse proxies if you've ever worked in it. They have buttons that you can click and you can just magically come up with an identity-aware reverse proxy in different environments. And it really makes things easier in many cases. You are testing something, you haven't gotten to authentication yet, but you can put this hardened, security-aware layer in front of your application to work with it until you can get your final application done. It's cool. So, but there are many different options for hosting them. There are open source projects. You can build some of it your own. And we'll get into that a little bit later. But at the basic idea of it, we're just checking the identity with the same process we talked about before. So it's still a reverse proxy. Your initial request goes to it, and it's forwarding to the backend servers. But before it's willing to do that, it says, do you have the right tokens? Are you who you say you are? And if you don't provide any of that, it says, you got to talk to my identity provider first, and I won't let you in until you've done so. And that identity provider could be lots of things. So it's very flexible. It could be Keycloak, it could be some kind of basic login, it could be Okta, it could be any IDP, but the basic idea is you're saying, you got to go there first. If you don't come with the creds from them, I'm not letting you in. Makes sense? So this is sort of the same thing as the last diagram, and I don't know whether it helps or hurts, to be honest with you, but this is how I think of it in my head, which is this breaks down each step at the kind of the request level. You're requesting to the IRP, then you're getting redirected for auth. The IDP says, who are you? Give me my login. They log in, they're authenticated. That gets them, they retry back to the IRP. They're told, go back again with your token and see if it'll give it a go. That says yes, but here's a couple more features that I think are really useful. It's not just that you can say, I am who I say I am. You can also say, well, do you have the right access to this particular resource? So it could be not just authorization, identity, but it can be authorization. So I think we call it auth N, auth Z in security terms, but just think of it like are you who you say you are, and do you have the rights to get to the thing? If you're an intern who has access to nothing at the company, we're still not going to let you in, even though you are who you said you are. Or maybe you're the DevOps engineer, you have access to it, no big deal. Okay, so what are the benefits? So it provides authentication for systems that don't support it. I think that is one of the major benefits. You can just put it in front of something. That service never supported authentication in the first place. Boom, we have a login. And we have something that attackers are going to hit before they get to that. Second, it enforces authorization and policies. We talked about that. Third, proxies requests to external services. It acts as a good reverse proxy. That's really nice. Another one is they often provide built-in SSL management. And look, we live in the age of Let's Encrypt. Like, there's really nice services for making your, pulling automatic certificates. But many of these have that built in. You just say, hey, do that, and then they do that transparently behind the scenes. And then last, there's been some real movement in this front where they're becoming something more like what we use VPNs for, where there are some that actually feature things like UDP, where you have to authorize first, and then you could do a UDP port to something internally. And on top of that, I've seen ones where you can do the login, and then it will actually let you do like internal SSH. So people are getting more and more complicated at this. At the very beginning, it was just, we need to log into a web server. People are getting more complicated where it's a full-on VPN replacement. So what are our options? I'm going to walk through two slides here. One is, in the spirit of our conference, open source, and the next one will be cloud. So Pomerium is an open source option for doing identity-aware reverse proxy. It can be integrated with any OAuth 2.0 identity solution, and I particularly like its policy rules. OAuth 2 proxy, this is kind of an older solution. OAuth 2 is used for lots of things. But it also works very well. When if I'm looking up identity-aware reverse stuff on Reddit and looking for answers for my solution, I often get people who are just like, I love this, and it works really well. So it's another good thing to look at. Authentic, much broader solution. You'll see that. These are often built into bigger solutions as one of the services that they do. And so, because I'm, in this talk, we're kind of building SPAL, that might not be appropriate for us, but it might be appropriate for a company. Authalia, it supports, again, integrated with popular identity providers. And last, the big dog in a way, Keycloak's authorization services. I say the big dog in multiple reasons. It's a giant Java app, but also it's really commonly used. It's considered a standard in industry. If you don't know how to make access work, you can probably figure out how to use Keycloak to make it happen. It is one of the many things Keycloak can do. I believe Keycloak is a Red Hat project. Primarily cloud, and this is how a lot of, I think, engineers at companies have been exposed to it, like me. We have Google Identity Aware Proxy, this is the one that got me into doing this. And I just think it's like they made it, the user experience is really good. You know, it's not hard to throw one up at any point in your environment. I think that's why it became popular as much as the technology. Microsoft Entra Application Proxy, this is the one of the three I haven't specifically used, but it is Azure's version of this. And Amazon Verified Access, which, I mean, it's, you know, it can integrate into AWS's own various auth solutions. It's one of the things that I think, particularly for these three cloud providers, what really separates them is while they're not as flexible as running it yourself, they're not. Like a lot of the features I've talked about, they can't do. They're really built to just put an auth in front of something. They are very easy, and they are usually managed services from your cloud provider, which means that they are the ones taking the security brunt of somebody trying to go over and over and over into them. And there is an upside to that. I mean, it doesn't solve all your woes. You know, somebody can still get through that with the wrong credentials or breaking into your Okta or whatever it is. But it does provide a piece in front of your application that your cloud provider is responsible for. I think that has a lot of appeal to many engineers. You know, managed services, it's a dangerous two-way game. It's the cloud providers often call it the trust barrier between them and you. And it's hard to know exactly where it is, but companies like the idea that it's on AWS's side or Azure's side. So let's look at the small scale. I think for this particular talk, that'll be really helpful. This is also useful in a home lab or a self-host scale. And I think that is something that I'm seeing less of. You know, these are common at companies, but I don't see them quite as often for people's own infrastructure. I think it's just, you know, if you've got something at home or you've got something on an instance that you hosted somewhere, it's tempting to just make a VPN because it works. And at one person scale, it works okay. You know, it works fine. But there are benefits to doing it this way. They provide some real convenience and security. You know, at a company scale, it means that people don't know the difference between an internal service and external service. They just go to their Okta, or I keep saying Okta because I've used Okta too much, but you know, either they go to their IDP, they click on a dashboard icon, and it just loads up and it's an internal service, and they don't know the difference. But at home, you still get some of those benefits. It's still easier to log in. You can access it from anywhere. You don't have to think about your VPN login and all of that. Another note here is this is something that we will expose to the internet typically, and that means some security consequences. Like anything you put on the internet is going to be scanned and attacked 24/7. If you look in the logs, you know, people are endlessly trying to brute force. They're endlessly trying to go in and log in as users that they found, credential stuffing. If you're not aware the internet is scary, I'm sorry. I'm here to tell you that it is. And so this is something that you should update. This is not something you should deploy and forget. And one of the things that this has really led me to do is, you know, at a big scale, at a company scale, your teams, you know, you have people who are responsible for these things. You can do some automation within your CI/CD or whatever to make sure that updates happen, but you can have validated versions that are updated and you check. At one person scale, that's probably less realistic and helpful. And so you look at a different threat model, you know, what am I responsible for? Who is likely to attack my application? And I think there are different good answers for just you running a service, but you still have to update it. These have vulnerabilities that'll happen every once in a while. That could allow access to bad guys into your services. You don't want that. So we need to make it updating. One thing that can be really nice is to make it self-updating. And this is not a clear-cut win. You know, if somebody, you know, if you're self-updating, that means you are accepting patches immediately and assuming that they will work and be great. And I can tell you from having worked in this field, that's most of the time true. But most of the time can be really bad, right? And so that said, if it's for your personal project, most of the time, you know, 99.99 whatever is really good. And perhaps relying upon an updating, you know, an auto-updating service can be better than you needing to check it every day to make sure there's a security vulnerability. And so I don't think there's a clear-cut answer here. I think it's something you need to decide, but I think it's reasonable at a small scale to do more auto-updating than you might elsewhere. So in this case, I'm going to be using Watchtower, which Watchtower automatically pulls images and runs them on Docker. Now, if you're thinking through this from a security perspective, there's two potential holes to this. It presents a supply chain risk, which is what I was just talking about. You are reliant upon someone else's container, and they better not put something bad in it, right? So you need to be aware of that risk. Second of all, in order to do this, Watchtower needs fairly serious permissions in your application, in your server. It's just how it works. And so I think Watchtower can be a good solution. I know a lot of people who run it in order to keep things up to date, but there are two sides to the security equation. So last, for one person, at a bigger scale, if you're running, a cluster, a Kubernetes cluster, you're running ECS and AWS, you can make it so that there's endless reboots going on or endless redeployments of containers, and the user never sees it. And I think if you're starting out with this stuff at home, that's not necessary. Instead, maybe you can just set it up so that Ubuntu automatically updates and reboots, and then you check it on a schedule. I think that's totally reasonable for a service someone is running at home. But again, these are the balances. These are the things you've got to consider. At the very least, if you're running it on an instance, if you don't want to run automatic updates, you should get into a very regular update schedule for the OS. So Pomerium, I'm going to focus a little on Pomerium here. It's just because I've used it and like it. This is not a vendor talk, so I'm excited to say I just happen to like the open source software. But also, I've not used Pomerium in production environment at any scale. I've used this all personally. I have used identity reverse proxies, but at a very large scale, but just never this particular tool. But I think it's really nice for hosting in a smaller environment, just because it's relatively straightforward in how it works. It also just has a very clean policy language. So it uses YAML. I'm sure that it evokes feelings from at least a few of you out there. But YAML can be very finicky about syntax. But if you get used to YAML, it can be very easy to read, and their particular way of laying it out I find pretty easy. Their creators regularly, there is a company behind it. They have a different product that has dashboards, which I don't use dashboards, but there is a company behind it which does updates. And notably, work in security, I will tell you, I check the CVEs of any project I'm going to use, and the answer is there's always something interesting. And Pomerium has had one critical security auth bypass that required a malformed packet to get around some of the potential policies. And they patched it immediately. And honestly, I'm not one to hold critical severe CVEs against a company if they're rapidly updating it, if the maintainers are updating and watching it. But you should know about it, which is why I put it here. So last, I've just found it works pretty well. So we're going to go and look in a little more detail at what the policy actually looks like when you're setting this up. So first of all, we're just going to use Docker Compose. Many of you probably, and this is really small, I bet. Let's see if I can.
That's so much better.
Yeah. So, they have a container that they host and do, which is just Pomerium/Pomerium latest. You can, there are, again, if this is of concern to you, you can you could set up something that regularly pulled their image. This is what companies do. Regular pull their image, put it into a repository, vet it, and then put it out in your infrastructure when you're ready. But frankly, risk is relative. I think this is a reasonable, particularly if you're learning this, a reasonable way to start. So we're just pulling their image. Then we are saying, use the config file that is within this directory and put it where Pomerium expects the config file. Ports, we've got 443 and 80. So what do these do? This is actually interesting. 443 is obvious. That's what it's going to serve all of your content in. And it doesn't matter what the underlying domain is going to be. It will know what URL was used to access it and understand that and give the right contact back. That's something wonderful that web servers do, but also identity-aware reverse proxies. So it will always serve it out of 443. What is 80 for? Well, one is obvious, it's for redirects. So if somebody came to your website on 80, come on, please use encryption, go back to 443. But it uses it for one other really important thing. If you ask it to handle your certificates, it will use that for validation of Let's Encrypt. So there are two ways to validate Let's Encrypt. One is through an HTTP challenge, and one is through a DNS challenge. The most straightforward one is just you own the server. Let's Encrypt is going to ask you on port 80, are you really who you say you are? Sends it back with a file, and that proves that you own the service, and you're good to have a certificate. DNS is the other way. You put a text file in the DNS. That is also possible within Pomerium. So you can set up a DNS challenge. I've done it. It can be useful in other directions, but here we're just using good old-fashioned HTTP UL1 challenge. So that's why we have to expose port 80. Restart unless stopped. This just says, unless I deliberately stop the container, please keep it going. And then next, I'm going to do, what might we put behind, what kind of fun things could we put behind an identity reverse proxy? One thing that came to mind is, I hear AI is a big right now. People think it's cool. There are interfaces for interacting with LLMs that are very flexible that you can host yourself. And one of them, the big name in it, is called Open Web UI. And what's nice about it is you can have an interface that lets you chat that looks just like ChatGPT, but then you can tell it, here's my local model I want you to use. Here, now I want you to go to Claude. Now I want you to go to OpenAI. And you can put all those in there, and you can flip between them and use them independently. I strongly recommend Open Web UI if you're interested in that kind of thing. But we're going to put it behind this identity reverse proxy. So in this case, Open Web UI comes with its own auth. And so what we're going to do is actually turn it off because we're putting our own auth in it. You can actually get more complicated than that. You can sync the auth essentially between the two so that the application understands it. I'm not going to get in depth about that. In this case, for my uses, it's perfectly appropriate to just have my auth instead of their auth, but I just want you to know that's possible. So for volumes, this is where it's going to put the data. You could have it be a Docker volume. You could have it, in this case, I've just made it a folder for ease of troubleshooting. And then I'm exposing port 80. Notice I used expose and not ports. In Docker Compose, which is one of the many ways to run these things, ports means to the world, 00000. Expose means expose it within the Docker network. And so that means I'm not saying that this Open Web UI is going to be exposed to the internet. I'm saying expose it within the private Docker network. So just with this Docker Compose, you'd never get to it from the internet. So next up, we've got Watchtower, which I told you about. Watchtower will automatically update these. And we'll pull on 60 seconds and then do cleanup. So basically what these are is how often does it check whether there's an update. You can actually do it remarkably often. Looks like we're having internet troubles, which is not terribly surprising, but I will we'll keep going and see what we can get. At the worst, I will talk you through the rest of it. So Watchtower also has an option called cleanup. That means that it deletes what it, if it makes a new image, it will delete the old one. Include restarting, so that if the container is in a restarting state, it'll update it anyway. Include and stopped, it will update it anyway, even if it's stopped. And then again, unless stopped. So what this will do is just make sure that that container is up to date all the time. So if there was a CVE, you would have the latest version quickly. Again, not a clear-cut security win, depends upon your environment, but it is an option that can potentially allow a small scale to have updates very, very quickly. Okay, so we're gonna see what we can do with this internet connection. So if we just do, so 1 second. Let's see if we can, I just suspect we lost it at some point. I can just log back in, so. Yeah, that one. Internet. Anybody out there? Let's try. Yeah, no internet. So, good news is I can talk you through the rest of this. Basically, the end result would be actually we can do a little bit more. Let me get back to it. I have a local version.
Friends don't let friends do live demos.
Yeah. No. They're fun. You find out what really works. Let's look at what I need is dismiss, don't care, file, open folder, and it really doesn't like this anymore. So let's go back to here. Let's go to Linux Fast Northwest. Let's go to code here. This is the local copy of the code, so we won't have all this fun. So let's look at the config. We can walk step by step through it. Basically, what this looks like is you would do a route, and first you go and you say the service URL. The authenticate service URL, this is actually a default that Pomerium provides as a login service that you can use if you're setting things up and learning. They're okay with you using it generally. There are limitations to it. It doesn't have, I believe it doesn't even have MFA. And so this is not something you would want to use in production. You would want to shift to your own backend provider, IDP provider. But they essentially allow it as a testing service. So put a very long password on it and you're in pretty good shape to start. And then what you would do is, let's actually, here, this is going to be better. Let's look at so this is a good example. You would make a route. So in Pomerium, you would go from, and you would say, this is the domain.com, right? And you would put a subdomain, and it will basically catch any of the subdomains that come in at this. We're doing QQ5. In this case, this is a real thing that I set up. And just to give you kind of an idea of the wild stuff you can put behind an identity-aware reverse proxy, this is a ScumVM instance that runs King's Quest V in a web browser. And so, yes, if I could get to the internet, I could show you King's Quest V running in a web browser, and you have to log in through Pomerium to get there first. I actually sent, my sister and I grew up, she also used that IBM PC. And we would take notes together on old adventure games, Myst, etc. And I sent her a link to this and was like, want to get through it again? And she's like, I'm kind of busy. I have a job. But we could both log in and control King's Quest V together because of the way I'd set it up. Then you actually have a policy. So when we say from to, it actually is, that's the external. But Docker itself, it's looking on the Docker like for that Docker name. So scumvm-web was the name of the Docker container. And the port that it ran on inside of Docker was 5800, which I just arbitrarily set. After that, you can set up a policy where you can say all kinds of rules about who you want to get in. So if you just trust, this is a security be aware. If you were to just trust Pomerium, put it at the top and don't put any policy, you are allowing anyone with a Pomerium login to log into it. And so you do need to say policy only these emails, only these users. And you can actually go really complicated. You can say if there's a group within your IDP, only this group. You can say only this group and not these people. You can say only this group, but it has to be an even smaller subdomain of this. So it's really flexible how you can move around that policy. And I really like that. Passing identity headers just allows the headers to be passed between the IDP. In this case, we're skipping TLS verify because it's on an internal private network, and it's not possible in this particular case to verify it. This does not mean we're skipping that for the world. Do not be too afraid here. And it actually does run over WebSockets, so we have WebSockets turned on. Again, very cool that they support WebSockets. That means you can do a lot of things that you otherwise couldn't do. Again, the end result of this is you log in, you get a Pomerium login, you type in your username and password, and boom, King's Quest V. Well, the next step from this is you can actually integrate an identity provider. And if you're building this at home, Auth0 provides free level of login. That is something I've seen used. Alternatively, you could stand up an identity provider. No one's stopping you. While you do that, I recommend you get a job in the tech industry because we'd love you. You know, I mean, it's not a trivial thing. But if you piggyback, it's very possible to piggyback on, you know, identity providers that you either already use or can set up at lower tiers. But it's very flexible. You can kind of do what you want there. But what would happen is it would redirect you to that identity provider. You'd log in with your MFA this time, with all of your security benefits, and there you go. You're set. It sends you back to the KQ5, and you play the game. It also manages sessions. So you can say within the identity provider and sync it with this, I only want to allow sessions to work for 24 hours, 12 hours, 4 hours, and it will make you re-log in at that time as another security benefit. So, you know, I think it's really flexible. There's a lot here we can do. I wish I could show you King's Quest V. You're just going to have to believe me. You know, it is a useful tool. So what's next here? Again, we mentioned you can self-host your authentication. I wish you luck. It's complicated, not impossible. People do it. You could tie it into an IDP. And another thing that you can do here is, this is the non-automated version of all of this. If we're looking at the small scale, Ansible would be great to set up this instance and maintain it. You could even maintain the policy with some of this. You could run it in CI/CD and have it all the changes be set that way. You could have custom Docker containers that are pulled down by Watchtower, and then those are updated within CI/CD. There's so many flexible options for how we could, mix and match this. And then you can scale it to the moon. Like there's this can go as big as very large companies. Very large companies use these. All right, that's everything. I'm out a little early, but you all can get some tea. Any questions at this point?